Hey everyone, my name is John Cosby, and this is my project on spam detection using machine learning. Basically, I wanted to see if I could teach a model to recognize whether a text message is spam or not just by looking at the contents. So, for this class, we learned a lot about different AI approaches. So, I wanted something simple, but also something real world. Spam detection fit that perfectly. I'll walk through the data set, the pre-processing, the models I use, the results, and then at the end I'll give a quick demonstration of the model in action. The objective of my project is pretty straightforward. Build an AI model that can tell if a message is spam or not. We all get spam texts. Sometimes they're obvious ads. Sometimes they look like fake USPS links or scams or something like that. My goal wasn't to build something insanely complex, but something clean, understandable, and useful. So I trained a couple of models, compared how well they worked, and looked at what kinds of messages they struggled with. I used the SMS spam collection data set. It has a little over 5,000 text messages, and each message was labeled either ham, which means it's a normal message, or spam, which means it was suspicious. And the nice thing was that the data set's already it was already labeled clearly, and the messages are short and simple. So short messages actually make the problem a little harder, but they also make the project really manageable. So I decided that that was fine. To prepare the data, I clean the text by lowercasing everything and removing stop words, and that's words like the, and, is, uh, words that don't really help much in identifying spam. Then I used the TF-IDF to convert the text into numerical figures, and that basically highlights the important words in a message, like common spam words would be like free, winner, claim, urgent. They tend to show up a lot more in spam messages. I trained two models, the multinomial Navy Bayes and logistic regression. Navy Bayes is super fast. It's used in real spam filters because it works well with text. Logistic regression is a bit heavier, but it often gives higher accuracy. So the cool thing is that both models are pretty simple, they're easy to train, and they're easy to compare. The workflow for the project is pretty clean, pretty simple. It starts with the raw data, it cleans it, it splits it into train and test sets, converts the text to the TF-IDF, it trains both models, and then it evaluates the results. Um, so there's no complicated architectures or um, any kind of like tuning. It's just a straightforward machine learning workflow. To evaluate the models, I used four metrics: accuracy, precision, recall, and the F1 score. Accuracy is just how often the model is right. Precision tells you out of all the messages predicted as spam, how many were actually spam. Recall tells you how many real spam messages the model is able to catch. And the F1 score is a balance between precision and recall. So for spam detection, recall is the most important because you don't want to miss the dangerous messages. So both models performed really well, but logistic regression ended up being slightly better overall. It had the highest accuracy and the highest F1 score. So Navy Base still did a great job and trained really fast. So in a real world situation, depending on resource limits, either one could be useful. But in this project, logistic regression came out on top. And looking at the confusion matrices, you can see where each model made mistakes. Most messages were classified correctly, which is great, but there were a few false negatives, spam messages that slipped through as normal, and a few false positives where normal messages were flagged as spam. Uh, False negatives are more dangerous. False positives are more annoying, I guess you could say. Overall, though, the models handle the data set well. So if you were to compare the two, Navy Bayes is extremely fast, has good performance, it works great for text-based problems, and the logistic regression has better accuracy in F1 score and a stronger overall predictions. So if I had to pick one for a production system with decent resources, I'd choose the logistic regression. There were a few challenges. The data set is not perfectly balanced, meaning there are way more normal messages than spam, and that can bias the model a little bit. Also, the text messages are super short. Like I mentioned earlier, sometimes they're only a few words long, so the model doesn't have much to go on. And some spam messages are written to look totally normal, so even humans could misclassify some of them. So, in conclusion, this project showed that even classic machine learning models can do a really good job at detecting spam. Logistic regression performed the best overall. Navy Bayes was still very strong and incredibly efficient. If I were to continue this project, I'd try using Ngram so the model can look at word pairs, or I'd try a deep learning model like an LSTM or maybe even Transformer. And all of my code, the data set, the notebook, and the results are uploaded to my GitHub. So if you want to see the full workflow or try the demo yourself, everything is available there. And I am going to do a quick demonstration of the project actually working so you can see it in action here. All right. So I'm going to run the whole code, and then at the end I have a cell just for a demonstration. So let me run this. Yes. Okay. Choose my spam CSV. Okay. So let's see, what is an example of a spam message? Let's say, congratulations, you won a free iPhone. Claim your prize. Whoops. Your prize now. Returns spam. Let's try it again with, hey, are we still meeting later today? Returns ham, which means it's safe. All right, so that's my whole project. Thank you guys for watching.